Preparing for a PL SQL Developer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between SQL and PL SQL? SQL is used to query and manipulate data, while PL SQL is Oracle's procedural extension around SQL. With PL SQL, I can declare variables, write loops, handle exceptions, create procedures, functions, packages, and triggers. SQL answers what data I need. PL SQL controls how business logic executes around that data. In real projects, I use SQL for set-based operations, and PL SQL when logic needs validation, branching, batching, or reusable database side processing. While answering, focus on SQL as a declarative query language, PL SQL as procedural extension, block structure, variables, loops, exception handling, stored programs, and when each is used. Question 2. Explain the basic structure of a PL SQL block. A PL SQL block has 3 main sections: declare, begin, and exception. The declaration section is optional and defines variables, cursors, or constants. The executable section starts with begin and is mandatory because it contains the actual logic. The exception section is optional and handles runtime errors. I think of a block as a controlled unit of work. Prepare data, execute logic, and handle failures cleanly before returning control. Make sure to cover declaration, executable, and exception sections, which parts are mandatory, how anonymous blocks differ from named blocks, and how variables and errors are handled. Question 3. What are implicit and explicit cursors in PL SQL? An implicit cursor is created automatically by Oracle for single SQL statements like insert, update, delete, or select into. An explicit cursor is declared and managed by the developer when a query can return multiple rows. I open it, fetch rows, and close it, or use a cursor for loop. I also use attributes like SQL%row count or cursor%found. Still, I avoid row-by-row cursors when one set-based SQL statement can solve the problem. In your answer, talk about Oracle-managed implicit cursors, developer-controlled explicit cursors, cursor attributes, lifecycle steps, use cases, and when cursor loops are less efficient than set-based SQL. Question 4. How do you handle exceptions in PL SQL? Exception handling lets me respond predictably when something fails. PL SQL has predefined exceptions like no data found, too many rows, and zero divide. And I can also define custom exceptions. In the exception section, I handle expected errors specifically and use when others carefully for logging and re-raising. I usually capture SQL code and SQL error into an error log. The key rule is never hide failures silently, because that makes data issues harder to trace. Be sure to mention predefined exceptions, user-defined exceptions, when others, SQL code, SQL ERM, raise, logging, transaction impact, and avoiding silent exception swallowing. Question 5. What are BULK COLLECT and FORALL, and when would you use them? BULK COLLECT and FORALL reduce context switches between the PL SQL engine and SQL engine. BULK COLLECT fetches many rows into a collection at once, and FORALL sends many DML statements as one bulk operation. I use them in batch jobs, migrations, and cleanup scripts where row-by-row processing is slow. I usually combine BULK COLLECT with limit to control memory. FORALL with save exceptions is useful when I want partial success with error tracking. While answering, cover context switching between SQL and PL SQL engines, bulk fetching, bulk DML, limit clause, save exceptions, memory trade-offs, and batch processing scenarios.
Question 6. What types of collections are available in PL SQL?
PL SQL supports associative arrays, nested tables, and arrays. Associative arrays are key-value structures, usually best for in-memory lookups and temporary processing. Nested tables are unbounded and can be stored in database columns, making them flexible for SQL interaction. Arrays have a fixed maximum size and preserve order. In interviews, I connect collections to bulk collect, FORALL, and table functions, because collections often become the bridge between procedural logic and set-based SQL. Make sure to cover associative arrays, nested tables, arrays, indexing behavior, storage differences, typical use cases, and how collections support bulk processing and in-memory manipulation.
Question 7. Why do we use packages in PL SQL?
A package groups related procedures, functions, variables, cursors, and types into one logical unit. The package specification exposes the public interface, while the body contains implementation details. I use packages for encapsulation, cleaner deployment, overloading, and shared session-level state when appropriate. They also improve performance because Oracle can load the package once per session. Good packages make database code easier to maintain, test, version, and reuse across application modules.
In your answer, talk about package specification versus body,
encapsulation, modularity, overloading, session state, performance benefits, dependency management, and organizing related procedures and functions.
Question 8.
What is the difference between a procedure and a function in PL SQL?
A function returns a value and can often be used in SQL expressions,
while a procedure performs an action and does not return a value directly. Procedures can still pass values through out parameters. I use functions for calculations, validations, or derived values, especially when they fit naturally into queries. I use procedures for workflows like loading data, approving records, or updating multiple tables. As a best practice, SQL callable functions should avoid unexpected side effects.
Be sure to mention return values, out parameters,
use inside SQL, side effects, deterministic expectations, business logic placement, and practical examples where each is preferred.
Question 9. What are triggers, and what are common risks of using them?
A trigger is PL SQL code that fires automatically in response to an event, commonly insert, update, or delete. Triggers are useful for auditing, enforcing complex rules, or maintaining derived data. The risk is that logic becomes hidden from application code, causing surprising side effects. Row-level triggers can also hit mutating table errors when they query the same table being modified. I use triggers sparingly and document them clearly, especially in systems with heavy transactional logic.
While answering, cover DML triggers, row-level versus statement-level triggers, before and after timing, auditing use cases, mutating table errors, hidden logic, and maintainability concerns. Question 10. How do transactions work in PL SQL?
A transaction is a logical unit of work that becomes permanent only after commit. Until then, changes can be undone with rollback or partially rolled back using SavePoint. In PL SQL, insert, update, delete, and merge participate in the current transaction. I avoid putting commit inside reusable procedures unless the procedure owns the complete business transaction. Otherwise, callers lose control. For logging independent of rollback, I may use an autonomous transaction, but only with clear intent.
Make sure to cover commit, rollback, SavePoint, transaction boundaries, DML behavior, exception scenarios, autonomous transactions, and why reusable procedures should avoid unnecessary commits. Question 11. How would you tune a slow PL SQL procedure? I start by measuring, not guessing. First, I identify whether the time is spent in SQL, PL SQL loops, locks, or external calls. I review execution plans, SQL trace, AWR or ASH if available, and log timings around key steps. Common fixes include replacing row-by-row logic with set-based SQL, adding or adjusting indexes, using BULK COLLECT and FORALL, refreshing statistics, and using bind variables. Every change should be retested with realistic data volume.
In your answer, talk about identifying bottlenecks, SQL trace, execution plans, row-by-row processing, indexes, bulk operations, statistics, bind variables, instrumentation, and measuring before changing code. Question 12. What are bind variables and why are they important? Bind variables are placeholders for values passed into SQL statements, like where employee ID equals /ID. They allow Oracle to reuse parsed SQL instead of hard parsing a new statement for every literal value. That improves performance, reduces library cache pressure, and helps prevent SQL injection when used correctly. In PL SQL, static SQL automatically uses binds for variables. The trade-off is that bind peaking and data skew can affect plans, so high-volume queries still need plan validation. Be sure to mention hard parsing, soft parsing, shared SQL area, performance, cursor reuse, SQL injection prevention, selectivity considerations, and how bind variables appear in PL SQL. Question 13. When would you use dynamic SQL in PL SQL? Dynamic SQL is useful when the SQL text is not fully known until runtime. Examples include dynamic table names, optional filters, generated DDL, or flexible reporting queries. For most cases, I use execute immediate because it is simple and supports binds. For more complex unknown column lists, DBM SQL can be better. I avoid concatenating user input directly because of SQL injection. If static SQL can solve the problem, I prefer it for readability and optimizer stability. While answering, cover execute immediate, DBM SQL, runtime object names, dynamic predicates, DDL execution, security risks, bind usage, and avoiding dynamic SQL when static SQL works. Question 14. How do you manage concurrency and locking in PL SQL? Oracle uses row-level locking, so concurrent sessions can usually work on different rows without blocking each other. When I need to explicitly lock rows before updating, I use select for update, sometimes with no wait or skip locked for queue-style processing. I keep transactions short, access tables in a consistent order, and avoid user interaction while locks are held. Deadlocks usually indicate conflicting update order or poor transaction design, not something to solve by random retries alone. Make sure to discuss row-level locks, select for update, no wait, skip locked, deadlocks, transaction duration, isolation behavior, and designing code to avoid long-held locks. Question 15. What is the purpose of %type and %ROWTYPE in PL SQL? %type anchors a variable to the data type of a table column or another variable. %ROWTYPE declares a record matching an entire table row or cursor result. I use them to reduce maintenance when column definitions change. For example, declaring vSalary employee's salary %type avoids hard-coding number precision. With %ROWTYPE, I can fetch a full employee row into one record. The benefit is cleaner code and fewer data type mismatch bugs, especially in large database applications. In your answer, talk about anchoring variable declarations to table columns or rows, maintainability, compile time behavior, reducing data type mismatch, and examples using records. Question 16. How do analytic functions help PL SQL developers? Analytic functions solve many reporting and comparison problems directly in SQL. Instead of looping in PL SQL to calculate ranks, running totals, previous values, or group percentages, I can use functions like row number, rank, sum over, lag, and lead.
This keeps processing set-based and usually faster. As a PL/SQL developer, I still write procedural orchestration, but I push data-heavy calculations into SQL whenever possible. That reduces code volume and improves optimizer opportunities. Be sure to cover window functions, ranking, running totals, lag and lead, reducing procedural loops, reporting logic, performance advantages, and combining SQL power with PL/SQL.
Question 17. What is a mutating table error, and how can you handle it? A mutating table error happens when a row-level trigger tries to read or modify the same table currently being changed. Oracle blocks this because the table is in an inconsistent transitional state. A common fix is to use a compound trigger. Collect row data during row-level timing and process it later at statement level. Sometimes the better answer is redesigning the logic into a procedure, constraint, or application workflow. I avoid forcing complex business rules into row triggers. While answering, explain why ORA 04091 occurs, row-level trigger restrictions, common bad patterns, compound triggers, statement-level processing, temporary storage, and redesign alternatives. Question 18. How do you generate primary key values in Oracle PL/SQL? The standard approach is to use a sequence or an identity column. With a sequence, I get the next value using sequence name.nextVal, often during insert. Sequences are concurrency safe and fast, especially with caching. I never use max ID +1 because two sessions can calculate the same value and collide. Gaps in sequence values are normal due to rollbacks, caching, or instance restarts. Primary keys should guarantee uniqueness, not necessarily perfect numbering. Make sure to mention sequences, identity columns, nextVal, curval, triggers for legacy patterns, gaps, concurrency safety, caching, and why max ID +1 is unsafe. Question 19. When should you use constraints instead of PL/SQL triggers? I prefer constraints whenever the rule is declarative, primary key, uniqueness, foreign key, not null, or a simple check condition. Constraints are simpler, faster, visible to the optimizer, and consistently enforced regardless of which application modifies the data. Triggers are better only for rules that cannot be expressed declaratively, like complex audit rows or cross-table procedural logic. A strong PL/SQL developer should not overuse PL/SQL where built-in database integrity features are clearer and safer. In your answer, talk about declarative integrity, primary keys, foreign keys, unique and check constraints, optimizer awareness, simplicity, reliability, and avoiding procedural enforcement where possible. Question 20. What is package state in PL/SQL, and what issues can it cause? Package state means package-level variables retain values for the duration of a database session. That can be useful for caching small lookup values or storing session context. The risk is hidden state, especially with connection pooling, where a session may be reused by another application request. Package recompilation can also invalidate state and cause ORA 04068. I use package state carefully, initialize it explicitly, and avoid storing business-critical workflow data in global package variables. Be sure to mention session-specific package variables, initialization, memory usage, connection pooling, ORA 04068, global state risks, and when package state is useful or dangerous. Question 21. What is an autonomous transaction in PL/SQL? An autonomous transaction is a separate transaction started inside another PL/SQL block using Pragma autonomous transaction. It can commit or roll back independently of the caller. The classic use case is error logging. Even if the main transaction fails and rolls back, the log entry remains. I use it sparingly because it can create consistency surprises if used for business data. It is a tool for independent side effects, not a shortcut around transaction design. While answering,
Cover pragma autonomous transaction, independent commit and rollback, logging use cases, visibility rules, risks of inconsistent data, and why it should be used sparingly. Question 22. How would you design error logging for PL SQL programs? I usually create a centralized logging package that records SQL code, SQL error M, dbms utility.format error backtrace, module name, key input values, timestamp, and user context. For critical error logs, the logging routine may use an autonomous transaction so the log survives rollback. After logging, I normally re-raise the exception, unless the business flow explicitly expects it. A good log should help reproduce the issue, identify the failing line, and separate expected validation failures from system errors. Make sure to discuss centralized logging procedure, SQL code, SQL ERM, backtrace, module names, input context, autonomous transaction, re-raising errors, and making logs useful for production debugging. Question 23. How would you process millions of rows in a PL SQL batch job? First, I check whether one set-based SQL statement can handle the work. If procedural processing is required, I process rows in chunks using bulk collect with limit and FORALL for DML. I design a commit strategy that balances undue usage with recoverability, and I log progress so the job can restart safely. I also review indexes, constraints, and execution plans before running at scale. For very large workloads, partitioning or parallel execution may help. In your answer, talk about set-based SQL first, chunking, bulk collect with limit, FORALL, commit strategy, restartability, logging progress, parallelism, indexes, and undue management. Question 24. What security practices are important for PL SQL development? Security starts with least privilege. Grant only what the package or user needs. I pay close attention to defier rights versus invoker rights because it controls whose privileges execute the code. For dynamic SQL, I use bind variables and validate object names to prevent injection. I avoid exposing sensitive details in error messages and log them securely instead. For production systems, auditing, role design, and careful access to personally identifiable data are just as important as code correctness. Be sure to mention least privilege, definer rights versus invoker rights, SQL injection prevention, bind variables, avoiding dynamic grants, data masking, auditing, and secure error messages. Question 25. How do you decide whether logic belongs in PL SQL or the application layer? I put logic in PL SQL when it is data-intensive, transaction-critical, shared across multiple applications, or benefits from running close to the data. Examples include batch processing, validation tied to database consistency, and complex stored workflows. I keep UI-driven decisions, orchestration across services, and rapidly changing business rules in the application layer when that improves maintainability. The best answer is not ideology. It is choosing the layer that gives performance, consistency, testability, and clear ownership. While answering, cover data locality, performance, transaction consistency, reuse, portability, maintainability, team ownership, business rule complexity, and balancing database-side processing with application flexibility. If you are still with us, congratulations! You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.